In this video, we are going to go over the process to create load versus deflection or load versus displacement graphs with results that you might get from MSC Nastran. So if we go here, this is the final graph that we want to create in this tutorial. And we are going to be using the HDA5 Explorer, and we are going to be using the post-processor web app to look at these loads and displacements. Let me go ahead and make a few comments about the web apps we are going to be using today. So today we are going to be using the post-processor web app. This tool and the HDA5 Explorer is free as long as you are an MSC Nastran user. If you're a student, researcher, or professional engineer, this tool is available for free for you to use. Number two, the web app is only compatible with MSC Nastran. These web applications are not compatible with any other version of Nastran. This is only compatible with MSC Nastran. So if you want to start using these web apps today, what you can do is visit the site theengineeringlab.com, and then at the top right hand corner, the blue button, if you click on that, fill out the form, and then we'll go ahead and start setting up the download for you to download the installer for the web app, install it on your workstation, and then you can start looking at Nastran results with the use of the HDA5 Explorer and the post-processor web app. And now, today's example is going to be Chapter 36, Shallow Cylindrical Shell Snap-Through. This example is from the MSC Nastran Demonstration Problems Manual, Implicit Nonlinear. So now, let's go ahead and get started with this exercise. So let me exit here, and let me go back to the home page of the whole web app. So this is the home page. And let me make sure my downloads directory is empty. The reason I like having an empty directory is just to avoid confusion with other files. And now what I'm doing is I'm navigating to the tutorial section to the very bottom of the post-processor tutorials table. Here, click on this link. This is going to download a zip file that contains the files we need for this exercise. So here is the bulk data file for the Nastran model, and then here is the H5 file that contains the results of that buckling analysis. So if we go back to the home page, this is what I'm going to do. I'm going to open the viewer web app. So here's the viewer web app, and I'm going to open the HDA5 Explorer. What I'm going to do now in the viewer web app, I'm going to import the bulk data file. And then here, if I want to, I can turn on the thicknesses of this very simple model. But I want to look at results. So what I'm going to do in the viewer, I'm going to upload the H5 file. And then here in the HDA5 Explorer, I'm going to open the H5 file. So I'm uploading the result files to the web app. Here back in the viewer, I now have a plot of the displacements at the first time step. But what I want to look at is the displacement at the very end of the analysis. So what we're going to do is mark this last checkbox. So if you look at this table, we have all the data from the analysis. Here you can flip through the different pages, and it's going to show you different time steps for the data. Here, if we go to the very last page and the very last row, this is the very last time step for the buckling analysis. Mark that checkbox and then scroll down. For the deformation, use a scale factor of 1. So when you use 1, this is going to give you the true and actual deformation. So here what I can do is, if I look at this from maybe the side, like I did here, I can turn off the deflection here. So I can turn it on and off, and you can see what the buckling shape looks like. Now let's go ahead and look at maybe the Y component of deflection. So here I've selected the Y component here, and what I can do is select a minimum label. So you can see that the minimum or the highest deflection here is happening at node 6. Node 6 happens to be where the load is being applied in this model. Now, quick comment about this example. When you read through the example here, chapter 36, and you look at this model, the load is being applied at the center of this mesh. This version of the model is actually a quarter version of the model. It's 1/4 of the original model. And what they've done here is they've used symmetry and symmetry boundary conditions to only analyze a quarter of the model. So just keep that in mind when you're going through this example. And now, what do I want? I want to get a time history. I want to get a load versus deflection graph for this node or grid 6. So back in the HDF5 Explorer, once you've uploaded the HDF5 or the file, let's go ahead and maybe redo this just so you can follow along. Let me close some of these items here. Let's go ahead and open the HDF5 Explorer again. Let's go ahead and upload the H5 file. When you upload the H5 file, it's going to go ahead and automatically extract some data from the H5 file. But what we want is data for specifically node or grid 6. So if we go to the plots browser, this is the first graph that's been created automatically. Here in the top right, click on the red X to delete that graph. So if you move up and down the web app, there are no graphs that have been created. Now we can build our own graphs that we want. For the displacement, let's go ahead and select the displacement dataset. Turn off auto execute. Type in node 6. Let me zoom in a little. So here we select the displacement dataset, node 6. Click acquire dataset. You can see that all the deflections for node 6 for all the time steps have been acquired and placed in this table. What I can do now is click create plot. When you click this button, create plot, this link in the navigation bar here at the top is starting to blink. Click on this link, last plot added, and this is the plot that's been created for the deflection at node 6 for every time step. So now that we have that plot, let's go ahead and create a plot for the applied load at node 6. So we'll go ahead and select applied load for the data set. We'll specify node 6 here and click acquire data set. Now we have the loads applied at node 6 for every time step. Here, click on create plot. Now this link is going to blink again. Click that link, and now we have the applied load for node 6 for every time step here. Now that we have those two plots, and here we're looking at the plots browser, here at the navigation bar, click on combine plots. This is where you can specify a data set for the vertical axes. So here I'm going to select the applied load data set. And then for the displacement, I'm going to select the displacement, or for the horizontal axes, I'm going to select that displacement plot we had a moment ago and click update plot. So here, let's go ahead and do a few other things. Maybe we are going to flip the vertical axes. And you can see this is the final graph that we wanted to do or create. This is our load versus displacement plot or deflection. And now when we look at the document here, let me scroll down a few pages. There's going to be one discrepancy that I have to point out. Here, if you look at the maximum value for this graph, they get a maximum value of 800. Here for this peak, they get a value of about 600. When you look at the graph, you do not get those values. You get a maximum value of 250, and then here at this peak, a maximum value of 150. The bulk data file that came with the documentation is not the same bulk data file that was used to create this graph. So this bulk data file that you see here, this bulk data file came with the documentation. This is not the same file that was used to create this graph. The bulk data file that we were given and when we went through the process, this is the load versus deflection plot we were able to create. Okay then, so then let's look at one last thing. If we go back to the post-processor web app, we see that at the very end, and here if we look at the domain, we're looking at time step 1. So here the time, frequency, eigenvalue. This means many things, but here in this case it means time. For one, the deflection at node 6 along the y-axis is negative 31.766. What we can do in the HD5 Explorer is look at the plot for displacement, which would be this one. And if we select the y component of deflection, if we follow this curve to the very end, let's go ahead and move to the very end, that's the value we get, negative 31.766. That's the same value that we saw here in the post-processor web app. So you can use both of these web applications together to look at your results for different time steps. Here in the post-processor web app, we looked at a fringe plot of the displacements. And then in the HD5 Explorer, we were able to quickly build these graphs. Now, I highly recommend those who are creating graphs with Nastran to consider using the HD5 Explorer. If you've ever spent hours digging around the F06 file, if you've ever had to use Excel or macros or a script to create your plots, you don't have to spend all those hours trying to build your plots. The HDF5 Explorer is a tool that can help you quickly create those graphs, as you saw in today's tutorial. And now, as a reminder, the post-processor web app and the HDF5 Explorer are both free as long as you are an MSC Nastran user. You can visit theengineeringlab.com. In the top right hand corner is a link, the free download button. Click on this button, the blue one, fill out the form, and then we'll get started in granting you access to the installer for the post-processor web app. So with that, as always, thank you so much, and I'll stop here.